Class, welcome to second unit, software requirement analysis and specification. So what are the things we are going to study? So let's focus on the first part called as syllabus. Here we will focus first part on what is software requirement, and then as per the software development life cycle we will try to follow a complete analysis phase. So in that perspective we are going to study problem analysis, then requirement specification, requirement validation and requirement metrics. So let's start with the first scenario, requirement. So what do you mean by the term called as a requirement? So let's take a simple example. Suppose you are in a cafeteria and you ask for a cup of tea. The waiter brings a cup of tea for you, and after taking one sip, you realize that there is no sugar in the tea. Will you accept that tea? Definitely not. So, what is your requirement? Cup of tea. But that requirement is in your hand, but still you are not ready to accept. It means, what is your expectation? That expectation should have some conditions and capability. So, understand the difference. So, to understand the difference, let's focus on the first part, needs. That is what user wants, and the second part is requirement. So requirements in technical language is nothing but needs plus some conditions and capability that must be get satisfied. So let me clear the first thing. User wants are known as a needs, that needs with some conditions and capabilities, then we will call it as one requirement. So what is the definition for the software requirement? Software requirements is equal to needs, user wants plus some conditions and capabilities, then and then only we will call it as what? Requirement. Are you clear with this? Okay, next move a more precise definition of the software requirement. So it is nothing but a condition or capability possessed by a software or a system component in order to solve a real world problem. It describes how system should act, appear or perform. It should differ one user to another and from one business to another. So requirements are nothing but user expectations with some conditions and capabilities which may be changing from one person to another person. So are you clear with the term software requirement? Okay, now to going further, we need to understand what are the different types of requirements, software requirements. So in general we says that basically there are three different types of software requirement. One is functional requirement, second is non-functional requirement, and third is domain requirements, or sometimes it is referred as constraints by the user. So what is functional requirement? That we will understood. So that functional requirements are the requirements which take behavior into the considerations. Non-functional requirements, these all related to the term called as what? Quality. And third, domain requirements are nothing but the special constraints. So to understand these types of requirements, we will continue with the same example. Suppose you are your task is to make a tea. So to make a tea, you need some basic components. That basic components are tea powder, sugar, milk. These are nothing but basic requirements called as a functional requirements. Okay. After collecting this, to make a tea, you need some supportive parts called as non-functional requirements. And after preparing a tea, how you are going to deliver a tea from kitchen to that or that person? How you are going to carry? You may carry in a single cup, or you may have a proper combination of cup and some biscuits along with that. How you represent? So that is nothing but domain requirement. So let's focus on in detail in each to the requirements. So moving towards further, these are the things what we need to take into considerations about the functional requirement. So simple definition about the functional requirement, simply remember the requirements which takes considerations about the input, which works on input and gives us an output, we call them as a functional requirement. For example, in case of calculator, functional requirements are all mathematical operations, all arithmetic operations rather, addition, subtraction, multiplication, division are example of functional requirements. Is it clear? Okay. So next, moving towards non-functional requirements. So to understand the concept of non-functional requirement, first we will take one more example. Suppose you are having an ATM card with you and you want to withdraw some amount from your account. So you are just entered into an ATM machines and you swap your card and entered your PIN amount, but that ATM machine took more than 1 hour time to give you money. Will you use such machine second time? Definitely not. So which factor you take into consideration here? The response time of that ATM machine. That response time is nothing but non-functional requirements. And in case of ATM, you perform and withdraw is your functional requirements. Are you getting? So non-functional requirements, as the name suggests, these are non-functional, means no any operations, but this supports to carry out the functional requirements. So sometimes it is referred as a supportive requirement, sometimes it is referred as a supportive requirements also. So for all types of software projects, my non-functional requirements are fixed one and known as FURPSS, which stands for functional, usability, reliability, performance, supportability, and security. So these are known as simply non-functional requirements. Third type of requirement, moving towards that third type of a requirement is domain requirements. As the name suggests, derived from the application domain of system instead from the needs of a users. Means suppose you are working on a calculator project and in that calculator you said that these are the buttons, but suppose that end user is saying is that rather than having single zero, I need three separate buttons, 1 0, 2 0 in a single button, 3 0 in single buttons, like this. So this will be that specific requirement suggested by that customers. Or sometimes while we are working on web development, customers say that I want you have to use my own logo, whatever that user has developed. So that is what, again, domain requirements. Color combinations, domain requirements. So these are the basic things. So what we studied so far: functional requirement, non-functional requirement, and domain requirements. So functional requirements, the requirements which take into consideration user inputs, works on that inputs and gives an output. Functional requirement, example in case of calculator is like all arithmetic operation. Non-functional requirements are the requirements which supposed to carry out the functional requirements, are known as non-functional requirements, and these are fixed for all types of a software project named as FURPSS, which stands for functionality, usability, reliability, performance, supportability, and security. In case of calculators, the response time, security, these are nothing but non-functional requirements. And the third type of requirement is called as a domain requirements, nothing but special requirements or some constraints, some user expectations that we have to fulfill at anyhow, named as a domain requirement. So are you clear with this? Now moving towards the next part is requirement engineering process. Now this requirement engineering process is nothing but, as it suggests, it is a series of activities that are performed in the requirement phase to express requirements in the software requirement specification document. So simply remember, the requirement engineering process is nothing but it is a way to compute or to collect the requirements, user expectations into a technical language called as the requirement engineering process. So we have to focus on this part. So this entire requirement engineering process works on various phases. So what are that various phases? If we focus here, the first thing we need to understand is feasibility study, requirement allocation, requirement analysis, requirement specification, requirements validation, requirements management. So let's understand each one of them. So simply focus on this diagram and I will explain each and everything. So as the name suggests, feasibility study. Now what is meaning of feasibility study? Simply remember whether the things you are going to work on project, the first part is analysis, and that analysis means you are going to find out the requirement. So before starting the finding out the requirement, make sure that whether the project is practically possible to implement or not. That process we are calling feasibility study. So practical extent to which a project can be performed successfully or not. This case we are calling as a feasibility study. So what we are going to do here as a part of feasibility study, we will determine whether the solution considered to be accomplish the requirement is practical and workable in the software or not. That process we are calling feasibility study. So simply remember, on a particular project you are planning to work, whether that project will complete or not. I am talking whether that project is practically implementation possible or not. We will call it as what? Feasibility study. So moving towards the next, after feasibility study, the next process is requirement allocation. Now allocation means nothing but just we have to capture. So sometimes it is referred as requirement acquisition or requirement capture. Allocations mean trying to find out. So as a process of collecting information from software requirement from different individuals such as user, stakeholders, project manager, consultant, etc. We have to understand, we have to interact with them, and we need to collect the requirement. So the simplest process we call it as what? Requirement allocation means to know the information. So how you will collect the information? So simply let's take a simple example. Suppose you have an open plot and your family members are trying to build an bungalow over there. So what you will do? You will hire an civil engineer or architecture, and that civil engineer is interacting with you by asking us some questions like in bungalow what you are expecting. So that nothing but the way he is interact and trying to collect the information. What is your budget, how much time you will spend, means what time you have given to me to go for the construction. These all the things that civil engineer tries to get. That process is nothing but requirement allocation. So simplest way to perform the requirement allocations are interviews, understanding the different scenarios, and understanding the interacts, organize the software requirements. These all simply we will call this process as requirement allocation. So simply questions, interrogations, and understanding the scenario. Like one more example is to more having clarification is you go towards a doctor, and doctor tries to understand what the problems you have by asking questions. What are the symptoms? Understand by the doctors. Nothing but requirement allocation process. Next process is requirement analysis. So what we covered so far: feasibility study, requirement allocation, and next is requirement analysis. Now what is difference there? Allocation and analysis. In allocations we just find out. In analysis we have to make it into a larger perspective. So in case of doctor and patient interactions, doctor find out what problems you have, allocation, and that problem's intention or the problem's level need to decided by the doctor, and that problem levels is nothing but requirement analysis. It helps us to understand, interpret, classify, and organize the software requirements in order to access the feasibility, completeness, and consistency of the requirements. So what are the things we need to take into consideration about the requirement analysis? To detect and resolve the conflicts, to determine the operational characteristics of the software. Also we need to take into considerations about analysis model to analyze the requirements in the softwares. So that process we are simply calling as a requirement analysis, and it can be recognized into the three parts. So simply we are calling as structured analysis, object oriented modeling, and many other approaches. So let's start with the first part called as what? Structured analysis. In structured analysis, this is simple as the name suggests. It's a top down approach. Here focus will be on the refining the problems with the help of functions performed in the problem domain and data processed by the functions. Second part is to structured analysis provides a graphical representation to develop the new software or enhance the existing softwares, and a common technique to used to perform the requirement analysis by using an approach called as a structured analysis is preparing a data flow diagram. So you might have studied C, CPP, Java. So the sequence is to know the problem statement, convert that problem statements into an algorithms, and understanding the algorithms you can draw the data flow diagram. So that process is called as what? Structured analysis. And this can be done to with the help of a data flow diagram. So how data flow diagrams are created? So these are the different notations should be given. Different notations are there. Abbreviations should and the most important part, as you all are aware about this, so I will not take much of time. So what is data flow diagram? It's a representation of the flow from inputs towards an output. So DFD represents the flow of data, whereas a flowchart describes the flow of control, and this can be represented into a different levels. So basically in DFD 4 levels are there. So remember, it starts with a level 0. So level 0, level 1, level 2, level 3. So what is the basic idea in level 0? It shows overall view of the system. Second is level 1, moving towards an more higher level. So we will call it as what? It elaborates means more details about the level 0. Level 2 elaborates level 1, and level 3 it elevates level 2. So same data flow diagrams into going towards in more and more details. According to that we will have a level. So minimum 4 levels should be there for any projects on which software project on which you are working. So remember, the level starts in DFD with the level 0, basic, level 1 detail, means depending on the modules, how many modules you have. For each module you can have level 1, level 2, level 3. So remember this. Next we are moving towards the analysis part by using an structured analysis, where we need to work on simply part called as a data dictionary. As the name suggests, it is a repository to store the description of a data objects used by the software. So it makes the different scenarios like name, lines, it's a descriptions and all the parts. So this is structured analysis. So simply remember, in third chapter precisely we are going to work on designing part. So in designing we have two options. One is function oriented approach and second is object oriented approach. That function oriented approach is nothing but structured analysis, and the next part is object oriented modeling, is nothing but object oriented design parts. So how you are going to perform the analysis? Maybe in structured manner or maybe in object oriented manner, or combination of this, that is allowed. So let's move towards the next part called as what? Object oriented modeling or object oriented analysis. Here each and everything, earlier scenario we focused on control and flow. Here we will focus on each and every individual involved in the project by treating them as an object. So as the name suggests, object is nothing but anything in the real world, maybe tangible, intangible, or maybe physics. We call it as one object. So once we know the object, for each object we have to remember state, behavior, identity, rules and responsibility. And each object oriented language works with the 4 pillars: abstraction, encapsulation, modularity and hierarchy. So with reference to that, we need to understand object, it's a structure, attributes, association. This association means relations, and what are the services that object can perform. So that is called as what? Defining the services. So this is the simplest chart to understand, and we'll take one more example to understand requirement analysis with one special diagram called as what? Entity relationship diagrams. So named as ER diagram for the banking system. So bank has a functionality like account. In account, what are the things you are going to do? It's a key features and all the parts. So we call that process as a requirement analysis. So what are the things we have covered so far? If you have gone through, we are working on a requirement engineering process. First is feasibility study, second is the requirement analysis, requirement allocation process, third is the requirement specification process. Now we will focus, if you are remembering. So the first part we have covered as a requirement engineering process, which is the requirement feasibility study, requirement allocation process, requirement analysis process. Now we are moving towards the next part called as what? A requirement specification process. Now analysis we know, Analysis is nothing but trying to find out how we are going to do this. Analysis is nothing but simply investigation. Simply remember, analysis is nothing but investigation. Now we have to write a specification for it. Means we have to provide more description of this, and whatever the requirements you captured, that requirement captured has to write us more description. In technical language we call it as one, writing it in a document called as SRS process, requirement specification process. So the output of entire requirement process is requirement specification document. So entire analysis is now we are going to cover as a part of requirement specification. So simply remember, the output of the requirement phase of the software development process is requirement specification, named as SRS document. So simply IEEE definition is there for the requirement specification as a document that clearly and precisely describes each of the essential requirements of the software with external interface. Means it has to provide a proper description about this process, and this SRS must have some characteristics. So before going for this, so each requirement what you have captured, that requirement must be some definitions or some characteristics named as correct, unambiguous, complete, ranked, modifiable, traceable, verifiable, and consistent. So let's understand each one of them. So requirement must be correct. It means we says that SRS is correct if every requirement including in SRS represents something required in final system. And SRS would be complete. It means an SRS is complete if everything the software is supposed to do and response to the software to classes of input data are specified in the SRS. Unambiguous, SRS is unambiguous if and only if every requirement stated has one and only one interpretation. It means the meaning you are getting should be one. There should not be no ambiguity. Then and then only we will call it SRS is unambiguous. Next is verifiable. Now SRS is verifiable means SRS is verifiable if and only if every stated requirement is verifiable. Now requirement is verifiable if there exists some cost effective process that can check whether the final software meets that requirements or not. We will call it as one, verifiable. Now next is consistent. As the name suggests, an SRS is consistent if there is no requirement that conflicts with another. Means it should have a independent interactions. Now ranked for importance and or stability. It means an SRS is ranked for an importance and or stability for each requirement. The importance and the stability of requirements are indicated. Means we have to give some priorities, and defining the priorities we have to rank it. Next is modifiable. As the name suggests, SRS is modifiable if its structure and style are such that the necessary changes can be made easily while preserving the completeness and consistency. And the next one is traceable. An SRS is traceable if the origin of each of its requirement is clear and if it facilitates the referencing of each requirement in future developments. So we will call it as one, traceable. Means if a small change in one of the requirement, how many other changes in the requirements I need to do, we call that as a traceability. So there are basically two types of a traceability, forward traceable and backward traceable. So simply remember, so just quickly go through this characteristics of an SRS. So what are the characteristics of an SRS? Correct, unambiguous, complete, ranked, modifiable, traceable, verifiable, and consistent. Remember this, there will be always question on this. So in the class I have given one simple case study and considering one requirement as a login, and you have to write the description for that login. So you can take the help of these 6 points: name of the requirement, flow events, which covers the basic two types of flows, basic flow and alternative flows. Then next we need to understand the constraints, domain constraints as a special requirements. Fourth is a precondition, fifth is a post condition, and sixth is an extension point. So with reference to these 6 points, you can describe the any requirement. So not only that requirements, any functional requirements you can able to modify with reference to these 6 points. And as I said, IEEE defines this SRS in a proper format named as an IEEE structure for the SRS. So this is the IEEE structure for the requirements, which has a very few points like introduction, overall descriptions, then product functions, user characteristics, constraints, domain constraints, assumption and dependency, then special requirements, input, output, interactions, some attributes, change management process, requirement approval, and supportive information. So this is what the one of the important parts. So remember this structure. There may be a questions in the university. Write the IEEE structure of SRS. You have to remember this, and for more description you can take reference of the 6 points into the previous part. So now moving towards the next part, we call that as a requirement validation. Means in case of feasibility study, then after feasibility study we focused on the part called as what? Requirement. Yes, any doubt there? No. Okay. Feasibility study, then requirement allocation, requirement analysis, requirement specification, requirement. Now next, validation process. Correct. Now in validation process, as the name suggests, whatever we find out, whether it is should be get confirmed or not. Now confirm means we have to make its implementation, possibly implementation into the final project on which we are going to work. So simply remember, requirement validation is nothing but in this phase the work products process as a consequences of requirement engineering are examined for its consistency and ominous and ambiguity. Means suppose we take into the considerations of the previous example, civil engineer and you say that I want bungalow. Civil engineer analyze it, one bungalow get converted into 2-bedroom hall kitchen, and next when the product is about to hand over to you, when you entered into that bungalow, you check whether the 2 bedrooms are there or not. Means what you said as a part of an SRS, you have a collection of a requirement. So each and every requirement is there into the final product or not. That process we are calling requirement validation. So simply remember this requirement validation process means ensure that SRS reflects actual requirements accurately and clearly, to verify that the SRS contains an acceptable description of the systems to be implemented, and to check a requirement document for completeness, accuracy, and technical errors. And this requirement validation process takes place into a specific format and represented in one diagram like user needs, expectations, problem analysis, requirement analysis process, product description, requirement specification process, and third is validation. Validation means confirm. Before starting a product we have to confirm that process. We are calling it as what? Validation process. And this requirement validation process can be remembered into the parts is what? Studies that the final draft of the requirements, that is what? SRS document, while requirement analysis studies the raw requirements from the system stakeholders. So simply remember, validation means confirm the things what user is expected, and all user expectations are covered into the documents before going to have an implementation process. That process we are calling as a requirement validation process. So remember, in this page the work products produced as a consequences of the requirement engineering are examined for its consistency, understanding the errors, and removing the ambiguity. It means requirement validation is nothing but is just for our purpose we can say that it's a process where MOU will be made between the end user and the software developer, stating that what user said is get covered into the SRS or not. We call that process as requirement validation process, and it can be remembered simply as requirement document to the list of this all the parts. So simply remember this process. This diagram itself is a self-explanatory to understand the concept of requirement validation. Now here, after requirement validations, the last phase we are calling as what? Requirement management process. Now as the name suggests, we find out the list of the requirements. SRS is with us. With that, SRS is validated, means an MOU signed. Now in actual implementation, whether that requirement came or not is the responsibility of a requirement management. So what actually the requirement management means? It is nothing but a process of allocating, documenting, organizing and controlling changes of the requirement. Means you said that I'm going to have a 2-bedroom hall and kitchen, and the construction is going on, and in between, suppose you got some extra amount as a user with you, and now you are communicating with the civil engineer side. Earlier my budget was only of a 2 BHK, but I have right now sufficient amount with me and I want to go for 3 BHK. So requirement is changed. How that requirement will be get managed, because the customer said 2 BHK now, earlier, now he is saying 3 BHK, and in the same premises, how you are going to develop this? Means in the same premises, means I am talking about in the same time durations. Budget is going to provide you the extra budget. How you will manage this? That process we are calling requirement management process. And this requirement management process works with the different scenarios, like it has planning, identifications, change, and means it is nothing but a change suggested by the users. Or maybe example is what we can say, that you said that earlier I am going to finish my project before the April 31st April, but unfortunately some viral diseases came like corona, and for that the state government has decided to have a complete lockdown for the next 15 days. So is it possible for you to cover the project less than 15 days? Definitely not. So this the change came. How you are going to manage that change with reference to the requirement, because you are going to miss your deadlines. That deadline itself is a requirement. So that process we are calling as a requirement change management. So this is the separate process we need to take into considerations. Changes, how you are going to handle the changes, we call that process as a requirement change management process. It works with a problem analysis, change analysis and change implementation. Whether whatever the change came, whether that change practically possible to accept or not. If possible, will be accepted. If not, will be rejected. If accepted, requirement traceability will be checked for the forward as well as reverse. How many other changes I need to do, and what will be the impact of that on my time, budget and quality. We call that as a requirement change management process. Now moving towards the last bit of the chapter called as a metrics for the requirement engineering. Now metrics, as we said, the simple point to understand metrics is nothing but measurement ways. Like if I says in our India, we take bananas in terms of dozens, the rate what we are giving in terms of a dozen. But in other countries, that same banana is measured in terms of weight, kg. So one thing can be measured it in different ways. Measurement techniques will be different. We are calling that as a metrics. So basically there are two types of a metrics: product metrics and process metrics. Similarly with the requirement metrics. So what the things we are going to see is how we are going to make this. For example, different attributes we need to take into considerations, like durations, length, rate, efficiency, quality, reliability. These are nothing but the attributes, and how we are going to measure this will be considered as a different metrics. So simply remember, these are the notations what we need to take into considerations while we are going to work on the software measurements. These are the some important notations, not part of syllabus but additional I have given for you. So any doubt so far in second chapter, software requirement? I hope everything is clear. You need more definitions, notes, everything is are available on my blog. My blog and details are given here. Just search on Google SomnathThigale, you will able to reach this. So thank you for the listeners. Thank you for your patience. Have a great day.